Good morning, students. This is Addagatla Nagaraju, working as lecturer in Electrical and Electronics Engineering, Government Polytechnic, Station Kanpur. Today, we are going to learn DEEE 5th semester's AC Motors subject. In that single-phase induction motors topic, we are covering. So, in single-phase induction motors, today we will cover shaded pole motor, comparison of different split-phase motors, speed control, and applications of single-phase motors we will cover. So, on completion of this topic, you would be able to know about shaded pole motor, components of shaded pole motor, working of shaded pole motor, torque speed characteristics of shaded pole motor, and applications of shaded pole motor. So, in the previous class, we had discussed about permanent capacitor motor, capacitor 1, capacitor start motor. We discussed it. So out of the 5 types of single phase motors, 4 single phase motors completed till now, and the last topic is the shaded pole motor. So we have already seen that capacitor start motor has high starting torque, and permanent capacitor has high power factor, and capacitor start capacitor 1 motor has constant torque characteristics. Okay, so these all we had discussed in previous classes. Now, in this class, we will discuss about the shaded pole motor, components of shaded pole motor, working of shaded pole motor, torque speed characteristics of shaded pole motor, and applications. These all we will cover in this chapter, in this lesson. And also, on completion of this topic, you will be able to know about the comparison between different types of split phase motors. That may be resistance split phase, capacitor start, capacitor run, permanent capacitor, only capacitor start, maybe shaded pole. So comparison between different types of split phase motors we will cover. Then speed control of single phase induction motors also we will cover. Speed control of single phase induction motors. Then classification of single phase induction motors also we will cover. Classification of single phase induction motors. This is the shaded pole type induction motor. This is the stator field winding. This is the rotor cage. This is the main flux. Here is the auxiliary flux. And the copper shadings are curved shaded flux, opposite direction. Copper shadings also there. Here you can find the connection diagram of shaded pole induction motor. This is the two-pole shaded pole construction. Here is the single phase winding. We form north and south poles, and this is the shaded point. These are the shaded coils, generally copper rings. This is the spiral cage induction motor. This is spiral cage induction motor. Construction of shaded pole induction motor. It consists of spiral cage rotor. Stator consists of silent poles. The poles are shaded. Each pole carries a short-circuited copper coil called shading band or shading coil. The portion of the pole which carries the shading band is called shaded part of the pole. The remaining portion is called unshaded part of the pole. So, it consists of spiral cage rotor. Stator consists of silent pole. The poles are shaded. Each pole carries a short-circuited copper coil called shading band or shading coil. The portion of the pole which carries shading band is called the shaded part of the pole. The remaining portion is called unshaded part of the pole. Unshaded part of the pole. This is the silent pole with shading coil. It is the copper shading band. This is the shading part. This is the unshading part. These laminations to reduce the eddy current losses. Shaded pole type, pole construction, copper shading coil. This is the shaded pole induction motor. Here is the single phase supply. This is the shading part out. These are the core. This is the spiral cage induction motor. This is the shading coil, copper ring. This is opposite direction. So, this is the shaded pole induction motor for varying speeds. So, shaded pole motor may be single speed or tapped multi-speed is shown here. Electrically and mechanically simple, it is inexpensive but has poorest efficiency. Poorest efficiency and starting cost also poor. So best uses are usually household rather than individual, industrial or industrial. So household applications we will use the shaded pole, but it has poorest torque and poorest efficiency, high losses. It can be single speed or multi-speed. Single speed or multi-speed motor. This is the shaded pole motor with flux distribution. How the flux distribution is varying, we will see. Four-pole shaded pole construction. This is the four-pole type shaded shaded part, this is the shaded part, this is the shaded part. Here it is a singleton copper wire. Copper wire of singleton used for shading the bands. Okay. These are the splitting the pole. This is the shaded part, this is the unshaded part. Shaded part, unshaded part, shaded part, unshaded. Spill phase rotor. North, south, north, south. Four poles. Alternating poles are north and south poles. So, coming to the principle of operation of shaded pole induction motor. Single phase supply is given to the stator winding to the shading band on the poles. A rotating magnetic field is generated here. This is the waveform of stator flux, alternating flux. Consider three instants T1, T2, T3 during positive off cycle of flux. At T1, current through the stator coil and flux increases due to rate of change of flux. EMF is induced in the shading band by Faraday's first law. This EMF causes current to flow in the short circuit shading band. Direction of current given by Lenz's law. It opposes the cause, that is, increase of flux of stator field. Hence, there is crowding of flux in the unshaded part, weakening of flux in the shaded part. Hence, the magnetic axis will be at the center of the shaded pole, unshaded pole. The direction of current given by Lenz's law opposes the cause, that is, increase of flux of stator field. Hence, there is crowding of flux in the unshaded part, weakening of flux in the shaded part. Hence, magnetic axis will be at the center of the unshaded pole. This is the magnetic axis at the time t is equal to t1. So, here is the main flux. This is the shading ring flux, and the magnetic axis is at the center of the unshaded part. At the center of the unshaded part. So, working of shaded pole induction motor. At the instant t is equal to t2, the stator current, hence the flux is maximum. The rate of change of flux is minimum. The induced EMF in the shading band is very small, hence opposition to the main flux is negligible. The main flux distribution is uniform and the magnetic axis at the center of the pole. So, at T is equal to T2, stator current flux is maximum. The rate of change of flux is minimum. The induced EMF in the shading band is very small, hence opposition to the main flux is negligible. The main flux distribution is uniform. Magnetic axis is at the center of the pole here. Here is the total main flux magnetic axis at the center of the pole, and here is the rate of change of flux is minimum, hence the induced EMF is negligible, hence the opposition force is 0. Hence, magnetic axis is at the center of the pole. At the center of the pole. At T is equal to T3. At T is equal to T3, the state of flux and flux is decreasing due to rate of change of flux. EMF is induced in the shading band by Faraday's first law. This EMF causes current to flow, the direction of which is given by Lenz's law. It opposes the cause, that is, it opposes the decrease of flux. The flux due to shading band is in the same direction as the main flux. So, there is crowding of flux in the shaded part compared to unshaded part. The magnetic axis shifts to the center of the shaded pole. The flux due to shading band is in the same direction as the main flux. So, there is crowding of flux in the shaded part compared to unshaded part. The magnetic axis shifts to the center of the pole. The flux due to shading band is in the same direction as the main flux. So there is crowding of flux in the shaded part compared to unshaded part. Shift to the center of the shaded pole. To the center of the shaded pole here. Magnetic axis at T equal to T3. Then the magnetic axis is at the center of the shaded pole. And the torque speed characteristics, here is the starting torque is very less, around 40 to 50 percentage of full load torque, and it's keep on increasing, then finally decrease. These are the speed torque characteristics. Speed torque characteristics of shaded pole induction motor. Coming to the advantages. Coming to the advantages, simple in construction, cheap in cost, extremely rugged, and no centrifugal switch is required. Same. Coming to the advantages of shaded pole induction motor, simple in construction, cheaper in cost, extremely rugged in construction, and no centrifugal switch. No centrifugal switch is required. No centrifugal switch is required. This is the shaded pole induction motor. shaded pole induction motor diagram here. Coming to the disadvantages. Starting torque is poor. We have already seen that starting torque is around 40 to 50% of the load. Efficiency is very low. It has more number of classes, hence the efficiency is very low. Very limited overload capacity. It has very limited overload capacity. So coming to the comparison of different split phase motors. This is the split phase motor. General type of motor, it has around 1 by 20 to 3 by 4, very less kilowatts motor, and its efficiency is approximately 0.65, 0.65, and power factor is approximately zero point 0.6, very less power factor, very less efficiency, low rating motor. Coming to the starting torque, medium starting torque, medium starting torque. Coming to the applications, fans, blowers, office appliances, low inertial loads, continuous operation of loads. These are the typical applications of split phase motor. Capacitor start motor. Capacitor start motor has also fractional kilowatt motor. It is HP around 1 by 8 to 3 by 4, and its efficiency also very less, approximately 0.6, approximately 0.6, and its power factor is around 0.7. It has very high starting torque, around 350 to 400% of full load. Coming to the applications, it is used in compressors, pump sets, air conditioner, conveyors, etc. Compressors, pump sets, air conditioner, conveyors, etc. Permanent split phase capacitor. Permanent split phase capacitor. Its HP around 1 by 22, 3 by 4. Its efficiency around 0.6. Its power factor is very high, 0.9, but it has very low torque, and direct connected fans, blowers, loads requiring low starting torque as the applications of permanent split capacitor motor. capacitor stop, capacitor run motor, its HP around 1 by 8 to 3 by 4. Its efficiency is very low, 0.6. Its power factor is improved 0.9, and its starting torque also very high. It is used in compressors, pumps, conveyors, high torque, low, etc. Coming to the shaded pole type induction, single phase induction motor, it is also very less fractional horsepower, 1 by 300 to 1 by 20. Its efficiency around 0.6, but its power factor is very low, 0.45, and also its starting torque very low, around 50% of low. It's also applications of fans, toys, hair dryers, and loads requiring low starting torque. Loads requiring low starting torque. Coming to the speed control of single phase induction motors. It can be done by the methods used for three phase induction motors: change of frequency, change of number of poles, change of voltage applied to the stator. Same. What are the methods we are using for squirrel cage induction motor in three phase motors? These methods are applicable for single phase squirrel cage motors. Change in frequency, change in number of poles, change of voltage applied to the stator. Among all the methods available, among all the methods available, the most economical method to change the voltage applied to stator, because the single phase induction motor used only in small sizes. Among all the methods available, the most economical method is to change the voltage applied to stator, because the single phase induction motor used only in small sizes. This can be achieved as follows: use of auto transformers. This method is expensive method, voltage changing method. It is also expensive. This can be achieved as follows: use of auto transformers. This method is expensive method. SCRs or triac circuit may be used to reduce voltage by AC phase control. A resistor in series with the motor gives very cheap method of voltage control, but it has disadvantage of reduced efficiency due to energy loss in the resistance. Shaded. This can be achieved. Voltage control method are achieved by use of auto transformers, but this method is expensive method. SCRs or track circuit may be used to reduce the voltage by AC voltage control, AC phase control. A resistor in series with motor gives very cheap method of voltage control. it has the disadvantage of reduced efficiency due to energy loss in the resistance. In the resistance. Coming to the comparison of single-phase induction motor with three-phase motors. Compared to three-phase motor, it has the disadvantage of efficiency is very less. Power factor is also very less. Starting torque is zero. It is no self-starting motor. That's why starting torque is zero. Needs auxiliary winding for starting purpose. This is increases it increases the size of the motor, and overload capacity also low. Cannot be run in reverse direction by change of supply terminals. You can change by either changing the auxiliary winding or main winding only. This is the three-phase motor. This is the single-phase motor. Three-phase motor runs from single-phase supply but does not stop. So comparison generally classification of different motors. Electric motors may be AC or DC. Coming to the AC, asynchronous or synchronous. And also coming to the asynchronous motor, it has AC brushed motors, universal motors. This maybe comes under DC also. Coming to the synchronous motors, sine, stepper, brushless, reluctance, four types of motors are available. Coming to the asynchronous motors, polyphase, single phase available. Coming to the polyphase, squirrel cage, wound rotor, permanent split capacitors, capacitor start motors, capacitor run motors. Coming to the synchronous motor, sine, stepper, brushless, reluctance. In sine wave, wound rotor, permanent magnet rotor, synchronous condensers. Coming to the stepper motors, variable reluctance motors, permanent magnet motors, hybrid motors. Coming to the reluctance motors, synchronous reluctance, switched reluctance. They are the electric motor family. Electric motor family. Single phase induction motors are fractional horsepower motors. These are classified according to the methods used to start them. Split phase motor, capacitor split phase type, shaded pole type, widely used for fans, washing machines, refrigerators, blowers, centrifugal pumps, toys, hair dryers, etc. Coming to the single phase induction motors applications such as clocks, recording instruments, teleprinters, etc., where the constant speed is required. Two types of synchronous motors commonly used are reluctance type, hysteresis type. Single phase commutator motors, AC series motors, universal motors. Series type can be used by either AC or DC. They provide high starting torque, operate at high speed. These are used in kitchen equipments, portable tools, vacuum cleaners, etc. Coming to the special purpose motors, stepper motors, servo motors. This is the single phase submersible pump set. This is the AC single phase reversible motor. This is the induction synchronous motor. Coming to the summary, we have discussed about comparison of types of split phase motors, speed control of single phase induction motors, classification of single phase motors. We had discussed comparison of types of split phase motors, speed control of single phase induction motors, classification of single phase motors, and also we have discussed shaded pole induction motor also at the starting. In shaded pole motor, the necessity phase split is obtained by using a shading pole on one side of the stator pole. No centrifugal switch. No centrifugal switch is required. The starting torque is less. So, in shaded pole motor, the necessary phase split is obtained by using a shading coil on one side of the stator pole. No centrifugal switch is required. Starting torque is less. Torque is less. Coming to the quiz, in a shaded pole motor, the rotating field is developed by using option A silent poles, option B capacitor, option B shading coils, option D any of the above. In a shaded pole motor, the rotating field is developed by using option A silent poles, option B a capacitor, option C shading coils, option D any of the above. So shaded pole induction motor shading coils will produce the rotating, will develop the rotating field. Okay, shading coils. Shaded pole motor is provided with option A laminated silent poles and a spiral cage rotor, option B a commutator, option C a capacitor, option D a centrifugal switch. Shaded pole motor is provided with option A laminated silent poles and spiral cage motor. Okay. A commutator is a wrong answer. A capacitor also wrong answer. A centrifugal switch also wrong answer. The shaded pole motor is provided with laminated silent poles and a spiral cage rotor. And a spiral cage rotor. Option A is the correct answer. Laminated silent poles and a spiral cage rotor. In a shaded pole motor, shading coils are used to option A reduce winding losses, option B reduce friction losses, option C produce a rotating magnetic field, option D protect against sparking. In a shaded pole motor, shading coils are used to option A reduce winding losses, option B reduce friction losses, option C produce rotating magnetic field, option D protect against sparking. So in a shaded pole motor, shading coils are used to produce rotating magnetic field. A rotating magnetic field. In a shaded pole motor, shading coils are used to option A reduce winding losses, option B reduce friction, option C produce rotating magnetic field, option D protect against sparking. We already discussed this. Produce rotating magnetic field. Produce rotating magnetic field. In a shaded pole squirrel cage induction motor, the flux in the shaded part always option A leads the flux in unshaded pole segment. Option B in phase with the flux in the unshaded pole segment. Option C lacks the flux in unshaded pole segment. None of the above. In a shaded pole squirrel cage induction motor, the flux in the shaded part always leads the flux in the unshaded pole segment. In phase with the flux in the unphased pole segment, lacks the flux in the unshaded pole segment. None of the above. So lacks the flux in the unshaded pole segment. In a shaded pole squirrel cage induction motor, the flux in the shaded part always lacks the flux in the unshaded pole segment. Shaded pole segment. Which of the following statement associated with shaded pole induction motor is incorrect? It is one of the simplest and cheapest single-phase induction motor. It has squirrel cage type rotor. It has high operating efficiency. It has laminated silent poles, each provided with its own existing coil. So it has high efficiency is the wrong answer. It is efficiency is very less, around 60% only its efficiency. Only 60% efficiency. Shaded pole induction motor does not have the advantage of high starting current is the correct answer. Rugged construction, wrong answer. Low initial as well as maintenance cost, wrong answer. Comparatively very small starting current, wrong answer. So high starting torque is the wrong answer. The direct